Welcome to Let's Talk Micro.
Hello, everyone. Welcome to another episode of Let's Talk Micro. As always, I hope you had a great week. Remember that Let's Talk Micro is available on Google Podcasts, Apple Podcasts, Spotify, Overcast, Stitcher, TuneIn Radio, Amazon Music, Pandora, Good Pods. Whatever you listen to your podcast, you can find Let's Talk Micro. I am also on Instagram as Let's Talk Micro, no apostrophe, and on Twitter as Let's Talk Micro 1. So go ahead and follow. I always like to post pictures of organisms and give updates as to when the next episode is coming out. You can, follow, leave any feedback, any podcast topic suggestions. They are more than welcome. If you haven't checked out the previous episode, go ahead and do so. It was an interview episode with Dr. Ayesha Khan. It was about Stenotrophomonas multifila and some challenges that it has in the lab. As you know, Stenotrophomonas multifila is a gram-negative rod. It's a non-fermenter. It is seen in ICU patients. It can survive in hospital equipment. It has a high level of intrinsic resistance for antibiotics. So there are many challenges. In this study, some Stenotrophomonas multifila isolates, they were tested in 3 different automated systems, and then they were compared against a reference method. So that's what the episode is about, about how did the instruments perform. And also, we talked about breakpoints and the challenges with that and some testing recommendations. Because if the systems do not perform well, we need to make sure that maybe that result needs to be verified. So it was a good episode. Some good information about Stenotrophomonas multifila. So if you haven't checked it out, go ahead and do so. It is episode 40. Today we have another interview. This time we are interviewing someone all the way from Australia. So Dr. Charlene Kahler. She is the head of discipline for microbiology and immunology and the Deputy Director of the Marshall Center for Infectious Diseases Research and Training at the University of Western Australia in Perth, Australia. So she came to the podcast and we discussed an article that she published in the Australian Society of Microbiology on May 2021. So, she does a lot of research with Neisseria. So we talked about Neisseria gonorrhea and all the other species, the ones that we consider them commensal, we call them the non-pathogenic Neisseria. So we talked about this and how, some species are seen in dental caries, about if we see some species, in genital sources, that it should be considered significant. We also talked about a relationship between Neisseria gonorrhea and lactobacillus. She also talked about an interesting mechanism, a DNA-dependent mechanism of Neisseria species that can actually kill Neisseria gonorrhea. So there's some good information about Neisseria gonorrhea, Neisseria meningitidis, and the non-pathogenic Neisseria, as we refer to them in the lab. We don't think much about these, right? We see gonorrhea in the lab, we proceed accordingly. We do our testing, we identify it. We provide susceptibilities. We do meningitis, and then the other Neisserias, typically we just report them as non-pathogenic Neisseria. We do a beta-lactamase, we typically don't do susceptibilities on them. So we don't think much about them. But however, there's some good information in this article that she discusses in the interview. Once again, Dr. Charlene Kahler from the University of Western Australia. So let's go ahead and listen to the interview. So today we have a guest to discuss a research article titled Neisseria Species and Their Complicated Relationships with Human Health. This was published in the Journal of Microbiology Australia from the Australian Society of Microbiology on May 2021. So here in Let's Talk Micro, we have Dr. Charlene Kahler. She's the head of discipline for microbiology and immunology and also the Deputy Director of the Marshall Center for Infectious Diseases Research and Training at University of Western Australia. Dr. Kahler, welcome to Let's Talk Micro.
Okay, thank you very much for the invitation, Lewis. I'm grateful for it and pleased to be here.
You're welcome. So let's start with an introduction and what kind of work does the Marshall Center does?
Okay, so the Marshall Center for Infectious Disease was set up when Barry Marshall won the Nobel Prize in 2005. And the centre has been running since 2007. We have about 20 academics there that work on a variety of infectious agents, anywhere from some parasitic diseases, tropical microbiology, sexually transmitted infections, and of course, Helicobacter pylori, which is what Barry won his Nobel Prize for.
So let's go ahead and talk about the article. Can you do a brief summary of it?
Okay. So, yes, my area of expertise has been in the Neisseria genus. And as your listeners are well aware, Neisseria genus is really interesting. It consists of two really well-known pathogens, Neisseria meningitidis and Neisseria gonorrhea, and a variety of commensal Neisseria species, which you may not be aware of. Those are all obligate human colonizers. And so my area of interest has been really devoted over the last 30 years of my career looking at the pathogenicity of Neisseria meningitidis and trying to understand how it causes disease, and more recently on Neisseria gonorrhea. And then even more recently still, really looking at how we now understand the role of commensal Neisseria species in human health and disease.
So as I was reading this article, it says that that Neisseria species in the female genital area should be investigated as a potential pathogen. Can you talk more about this, please?
Well, so one of the very interesting things that we kind of not really paid much attention to is that some of these other commensal Neisseria species have really important roles in the development of other types of chronic diseases, and one of those is dental disease. So Neisseria subflava is actually a foundation colonizer. It's really sticky, it sticks to your teeth. And so because it has that capacity of sticking to your teeth directly, it then becomes an organism around which other microorganisms actually start to build on top of it. And that is basically what dental plaque is. It's a mixture of these Neisseria species plus our major dental pathogens that are involved in causing dental caries and eventually leading to rot. So really there, Neisseria is playing this really important role in the establishment of dental caries, and then all the pathogenic organisms coalesce around that to create that plaque structure, which is then going to change the metabolism of the plaque to be producing more acid, and that is what starts eroding teeth and causing dental.
Like as far as us in the in the lab, we get the culture, we put it on media, we grow it, and then we look at it, and then based on what we have, we report it. If it's pathogenic, we go that way of identifying it, susceptibilities if indicated. So with this organism, so now that you mentioned that it causes with dental caries, and so if we get it in a source like this, should we properly identify it and perform susceptibilities on it?
Look, I don't think so. I mean, basically, dental caries is not a condition that you treat with antibiotics. And so really, I think this is much more about the basic biology of the species and thinking a little bit around how we might think of early biomarkers to detect the risk of forming dental caries. And that's a big investigative area in research at the moment, is trying to understand how you would actually identify children at very early stages with increased risk of formation of dental caries, because we know that we have a very high level currently of children with dental caries in the pediatric population. So even when children these days are getting their first set of teeth, we know that there is a larger group now that is going to hospital for medical interventions because their teeth have rotted. And so thinking about how to actually create early tests and therefore bringing it to the fore of the attention of the parents about how to manage the oral health of their children from a very early age is really important. And so one of the questions arises is that if Neisseria subflavor is so early on as a colonizer, being important for establishing that early age dental caries, whether having a test, a simple test around its early identification might lead to an association with risk around formation of dental caries. So looking at it as an early intervention marker might be a good thing to think of.
Okay, and I just wanted to I just want to clarify, because when I was thinking about the susceptibility, so what if we get it from, if we see it in a genital source?
So the urogenital tract is really an interesting mucosal surface in itself, and its biology is radically different. Every mucosal surface of the human body has its own microbiome, and they are all characteristically colonized by a different range of microorganisms based on the conditions that are at each surface. So when we look at the urogenital tract, one of the very interesting things that's coming out of all of the research around the microbiome and the natural health of the urogenital tract, and by and large, most of that material is coming from studies on female urogenital health and vaginal health. We're finding here that Neisseria species are unusual interlopers into that space. Typically, in those microbiome studies, they see Neisseria as a transient, low abundant colonizer. The species that are there are really understudied. We understand that Neisseria gonorrhea, when it's present, is clearly a pathogen, and its only mode of interaction with the human host is as a pathogen. It causes pain and inflammation and damage. So it's always in that role in the urogenital tract. And the question is whether any of the other Neisseria species could create that kind of effect as well. And one of the things that has happened more recently over the last 5 years is the appearance of Neisseria meningitidis in this unique microbiome to become a pathogen there. So we're now seeing a urogenital isolate of Neisseria meningitidis causing outbreaks of urethritis in the US particularly. And there's a lot of interest in surveillance networks around the world to see if there are other instances of this particular lineage appearing. So the more we look, what we found though is that Neisseria meningitidis has been a transient low abundant colonizer of the urogenital tract. Now people are looking, they start reporting that they do see a very low level of Neisseria meningitidis in urogenital secretions from various people with certain risk behaviours, and that it can cause urethritis even if it's not belonging to that particular lineage. So anyone who's in a medical diagnostic laboratory, I think it's really important if you see some other Diplococcus and if you have that it's not positive as Neisseria gonorrhea, pursuing it and understanding whether it's Neisseria meningitidis is really important for our understanding of how we see transmission networks appearing for these species. The most important point of all of that is that Neisseria gonorrhea is not just staying in the urogenital tract anymore. We now see that Neisseria gonorrhea is actually colonizing the pharynx, which is usually the home for Neisseria meningitidis. And it's taken a while. There's been some really big studies done now, but we've come to understand that Neisseria gonorrhea can hang around in the nasopharynx for at least 6 to 12 weeks. And that actually is sufficient to enable it to use that site as a mode of transmission as well.
So as I was reading the article, there was a mention about, a relationship between Neisseria gonorrhea and lactobacillus. Can you talk more about that, please?
So coming back to the holistic way we look at samples now, if we think about the human body, each site has its own microbiome. And when we look at the urogenital tract, the vaginal microbiome typically has about 8 large community structures. And a really healthy community structure is predominated by lactobacillus. And that actually is because the urogenital tract of females is at a low pH, it secretes a lot of acid, and it contributes to this sort of natural immunity state, which is keeping the pH low, colonizing the surfaces, and really keeping out all these pathogens. So lactobacillus is a competitor, which is a good one for us, which excludes or inhibits Neisseria gonorrhea. And we know that that's actually a thing, because we know that if you are exposed to Neisseria gonorrhea, you have a naturally healthy microbiome, you're not necessarily going to contract that infection initially because your microbiome is sitting there helping to exclude its colonization, so it can't establish itself. But if there are other disruptions, and this is particularly in women where you see menstrual cycles coming into play, and that changes the microbiome, then that actually leads to this ability of the gonococcus to take advantage of this disruptive environment, then it actually colonizes. So there is a lot of work around at the moment thinking about whether or not you can harness that effect, which we observe naturally, and thinking about whether, using lactobacillus as a colonizer for those women who may have other disrupted microbiome states, such as those who have bacteriovaginosis, whether they could go on to some sort of probiotic therapy, and that might actually restore the balance and help them protect themselves from this particular STI.
Can you talk about more about the DNA-dependent mechanism of Neisseria species that can kill Neisseria gonorrhea?
So this has been a really recent discovery. This was made by Madeline So in the USA just a few years ago. We've known forever that species are really interesting because what they have is this natural ability to take up DNA and incorporate it into their genome. And this is a way of, passing traits between the different bacteria species. And this actually, we followed a lot because we can see them sort of taking a trait from one bacterial species and adding it to their own collection, then using that to establish themselves in a better niche. But what she showed, which is really interesting, was that these exchanges between Neisseria species could also be deleterious, in that if the bacteria were growing very closely together in a single clump of cells, they actually used the machinery that was naturally being used to secrete the DNA to actually inject it physically into the cells of the other species, and that actually is toxic, because you then inject all of these other things in there with them, and the DNA basically incorporates itself, gets chopped up into little bits, and effectively kills the other species. So we found that the commensal Neisseria species use this particular feature to kill not only Neisseria gonorrhea, but Neisseria meningitidis. And that is something that people are actively looking at there to see whether or not you could, again, use these naturally occurring commensal Neisseria species as a potential probiotic that might prevent colonisation by gonorrhea in particular.
Yeah, this is definitely, very interesting as far as, us in the lab, we work with them, and, a lot of times we don't think much about them. And, now the audience can, learn all this about them. Like typically, mostly if we identify it as one of these, like, Neisseria species, most of the time they get reported as like a non-pathogenic Neisseria. And that's it. I mean, sometimes, if the source, if it's like pure, we go as far as maybe doing like a beta-lactamase test, and then we report that. But definitely, there are all these interesting facts about them.
Well, I think one of the last facts I'd like to sort of iterate is that not only do we see these Neisseria species in those two areas, that pharynx and urogenital tract, but remarkably, people are starting to see them as key biomarkers to dysbiosis in other states associated with the lung. So I've seen studies where people have been looking at cystic fibrosis patients who, as you know, they generally have problems with their mucus secretion and they succumb to Acinetobacter or Pseudomonas infections. But they're now finding that one of the key genuses that turn up very early on in this is Neisseria lactamica. So what we're seeing is that I think there's a broader role in understanding these low abundant transient colonizers. I tend to feel that the more work comes out in these areas, we're going to see that they are almost like the canary in the coal mine. You don't expect to see them when everything's happy and your microbiome is functioning properly, but you might expect to see them when something is going wrong. And this is now becoming a bit of a theme. I work with a world-renowned expert in this area, Mark Nicol, and it's really fascinating because you can see in that field Neisseria species turns up regularly as one of those key genuses where you say that's not where they should be, and they've turned up all of a sudden. So there's going to be a lot more interest in trying to broaden our understanding of this genus into the commensals and how all of this leads us to an understanding about what is a happy, healthy microbiome, what is actually a dysfunctional one, how that leads to this idea that you're headed towards a severe or deleterious illness in all sorts of different spheres.
And are you currently working on any research on Neisseria gonorrhea?
So my recent work on Neisseria gonorrhea has been around the genomic epidemiology of Neisseria gonorrhea in Western Australia. As I was saying to Lewis earlier on, Western Australia is a fascinating place in which to do this kind of research because we are the most isolated city in the world in Perth. We're equidistant from New York, whichever way you fly around the globe. And even within our own country, it's a 4-hour flight to the top of our state and a 5-hour flight to the East Coast. And so we are actually a very large state. We're the second largest state after Siberia in Russia. And so it's a huge landmass. But we're very sparsely populated. We have metro areas and when we have remote communities, mostly around mining. And those people in those areas are typically our Indigenous populations. So I did a lot of genomic, and what we know from surveillance operations here is that we have relatively low levels of gonorrhea in our metro areas because we're adequately treating them with antibiotics and detecting them early and stopping transmission. But out in remote areas, they have very sporadic access to healthcare. Typically, it requires someone to go out in a mobile van once a week or once a month, depending on what that rota looks like. And so you have to be ill on the day that van arrives. And so if you have some kind of illness, you won't get treated initially. And if you don't feel the symptoms on the day, you may not be treated for a month. And so we're seeing a disconnect here about what the rates of gonorrhea are in those remote areas. In fact, they're one of the highest rates of gonorrhea in the world, of around about 1,000 per 100,000, whereas in our metro areas, they're around about 90 per 100,000 population. So we were trying to understand what was going on in these two different sort of health jurisdictions, and our genomic epidemiology there has shown us that what we see is a huge amount of national and international travel associated gonorrhea in metropolitan and rural areas, whereas out in the remote areas, we're seeing that they have a unique set of strains that are unique, interestingly, to Australia. And they haven't been put into the genetic record elsewhere as of yet. So at the moment, they look remarkably unique. And so we think that the first introduction of gonorrhea into those communities occurred, we don't know when. Maybe these might be really early strains from early settlement, we don't know. And that they have continued to circulate in those communities without sort of moving outside of those networks, whereas in the urban areas, we see waves of antimicrobial resistant strains being introduced, but also waves of antimicrobial sensitive strains being introduced internationally as well. And in fact, our last surge in case numbers in our metro area was from an antimicrobial susceptible lineage from the UK. So it's a fascinating place to work in when you look at genomic epidemiology like that and trying to, unpick how these risk factors work in terms of where the disease is occurring in what at-risk groups and then how you go ahead to intervene and treat them.
Fascinating. And then the Marshall Center, you can actually see there's like a little video that you showed me that's on YouTube. So if anyone is interested to see what kind of work they do, they can go ahead and search it.
Thank you very much.
You're welcome. So, Dr. Kahler, it's been a pleasure. Thank you so much for taking the time to come to Let's Talk Micro and talk about this.
Look, thank you very much again for the invitation. And again, if you find any of my other colleagues interesting to talk to, please do contact them. I'll recommend you for sure. Thank you very much.
All right. Thank you so much, and have a great day.
Thank you, Lewis.
And that, my dear audience, it's the end of this episode. I hope you enjoy listening about all this information about Neisseria with Dr. Kahler. As always, I enjoy sharing this information with you. Continue bringing that passion to what you do. It's so important. We are coming on a period of 2 years where we have been overworked. So staying motivated, bringing that passion is very important. Thank you all for the work that you have done. So as always, stay motivated, stay safe, and of course, continue talking micro. Until the next time, bye.